Up until today, you had learned to recognize there's a hole on this one. And you were able to tell the other thing that crashes the function. And there's two things that crash this function. One's a hole and the other one's a what? Asymptote. Were we talking about horizontal or vertical asymptotes? Vertical. Those were vertical. What do you think today is? Horizontals. Very good. Okay, so by now I hope you've already canceled that, and this is important, rewrote the answer as 1 over x plus 5. Now I want you to think about this for a second. Is this exactly the same as that? No. Because the first one had an allergy to negative 3's. The second one doesn't. You get what I'm saying by that? The first one, if you put in a negative 3, it would have crashed it because it would have ended up with a 0 on the bottom. 0 times anything is 0 denominator. You're not supposed to have that because things like 8 over 0 aren't allowed. You try asking your calculator that, and it'll say either domain error or it'll say error. Okay, basically it can't handle 0 on the bottom, so we don't want that. So this can make 0 on the bottom, and so can this. One of them, that kind, where it didn't cancel, that's a vertical asymptote. This kind was a hole. And then the last piece was, what's the domain? The domain is what can you safely feed this function. This function has an analogy to two things. So you can safely feed it anything except peas and carrots. Or in this case, negative 3's and negative 5's. If you feed it a negative 3, it'll have a hole reaction. If you feed it a negative 5, that'll cause an asymptote in your function. All right. The new part is how we tell what the horizontal asymptote of this thing is. All right. So I'm going to just jump right to that part just to like give you a preview of it. Whereas this told me the vertical on the bottom, this whole thing, the function that results, I look at whether it's bigger on the top, bigger on the bottom, or same on both. And this one's bigger on the bottom. Why? Because it's got more numbers down there? No, because the degree is degree 1 on the bottom. And I'm going to tell you the rules for each case. If it's bigger on the bottom, that's called a bob, B-O-B, bigger on the bottom. And this one's bigger on the bottom, and so therefore the rule for bobs is it's y equals 0 or whatever's on the outside of the function. Because, do you get if I wanted to move this whole function up 1 and I put a plus 1 right there, everything would move up, including the asymptote. That's why we need to factor in whatever's on the outside. That's the new stuff for today, and I just taught you bob, but there's also sobs, same on both, and bigger on bottom, bigger on top, same on both. Those three. Bigger on bottom, bigger on top, or same on both. Those are the three different cases we have to study today. But that's to tell the horizontal asymptotes. All right. What you knew would allow you to be able to answer this question if you really understood yesterday's stuff. You should be able, plus 6 and y minus 7, or x minus 7. You should be able to tell me the domain of this. What can you safely feed this function? You should also be able to tell me the vertical asymptotes and if there's any holes. If you have the hole, you got to tell me exactly where it is. Like example 2 comma negative 9/3 or something like that. So you got to give it to me as a point. All right. I'm going to pause for a second while you give that one a try. The review from yesterday was verticals and the domain and holes. Here we go. So on this one, I hope you noticed that this part factored. Because if you can factor it, you should. Now, does anything cancel? Now, usually we set these up so that stuff will cancel. Did anything cancel? Well, let's see. What did you think it was? Do you think it factored, first of all? Okay. So then it had to be a plus and a minus. Why do I know it had to be a plus and a minus? Because the last number was negative. So then what was the last number of the original problem? A 6, a negative 6. So do you get these two numbers have to multiply to negative 6? All right. And was it that? Okay. Now, is that going to make something cancel? Yeah. Was it guaranteed something was going to cancel? No, not until you factored that and you just checked. All right, so something does cancel, and that creates a what? A hole. And the hole is at negative 6, not positive 6. Why? Because that goes in and makes it 0. That's what causes the problem, is there's a 0 on the bottom. Negative 6 comma what? Well, I hope some of you took the time to rewrite what you actually have after that canceled. I call this the resulting function. That results after I cancel stuff. Why is that one important? Because if you were going to graph it, that's what you'd graph. And if you're going to find out where the hole is, that's where you'd put the negative 6. How many of you knew that you were supposed to put the negative 6 right there? Okay, good. Then, this is negative 7 over negative 13. The negatives cancel 7/13. I know it's kind of gross, but you'd have to be able to do that on the test. All right, next, the vertical asymptote. That's the other thing. This one was a hole. This one is an asymptote. And I all the time have people say 1 is an asymptote. No, it's not. I get that 1 makes the top 0. We don't care if the top is 0. So don't look at the top. It's just all about the base. Thank you, Megan Trainer. And that is 7. So then it's x equals 7. Ooh, I'm a little scared for a second. Did I write the right letter? You should be scared, because if you write a y equals instead of an x equals, you'll lose the points. That's a vertical, and zertical goes with vertical. That's why I made up that dumb word. And so it's x equals is correct. X equals 7. And last but not least is the domain. I said yesterday that I recommend the easiest way, unless they say it has to be interval notation, is to say, here's the two numbers that don't work, and everything else does. To me, this is faster. I checked one the other day, and it was 20 characters. 20 to write out all the parentheses and brackets and the commas and U in between. Okay, so I like this way. What are the two things it can't be? Negative 6 and positive 7. Could I write that as negative infinity, comma, negative 6, parentheses, union, parentheses, negative 6, comma, 7, parentheses, union, parentheses, 7, comma, infinity? Sure, but this is faster. Raise your hand if you had all of these right so far. Okay, awesome. Now here's the next level. What would the horizontal asymptote be? All right. Remember me saying there was 3 things? Bigger on bottom, bigger on top, or same on both. Remember, it's not about how big the numbers are, it's how big the degree is. The degree is the little power that's on the x. These both have a power of 1. So that means it's the same degree on the top and bottom. That's the same on both. If it had a bigger degree on top, that would have been a bigger on the top. So it's either bigger on top, bigger on bottom, or same on both. All right. So if this one's the same on both, now I need to give you the rule for that. The same on both one is horizontal asymptote would be y equals, remember the horizontal tie there? The y equals, and if it's same on both, it's a ratio of the lead coefficients, which is a 1 and a 1, so it's 1 over 1, which is 1. I'll get deeper on that, but that's a little preview of how you find the horizontal asymptotes. All right, I'm going to pause for a second. If you needed a good excuse to get good notes for yourself, this one is the one you're going to want to refer back to on the night before the test, because these are the rules that everybody forgets right before this test. They're the rules for the horizontal asymptotes. They're not that hard, but they're kind of extensive. There's 3 parts, and so definitely take good notes on this. There's three choices. They're either bobs, sobs, or bots. I've already said it enough times. I think you're going to get this. What do you think bob stands for? Bigger on the bottom. How about sob? Same on both. And bot? Bigger on top. Now, there's no order this has to go in. But every fraction function is either bigger on the bottom, bigger on the top, or same on both. Here's an example of a bob where it's bigger on the bottom. If you had y equals 2 over x plus 3, why is it bigger on the bottom? Not because there's two terms. Because the degree is 1 on the bottom. On the top, the degree is technically 0. Because think about it this way. Couldn't I put an x to the 0 up there? That's why it's degree 0 on the top. So this is degree 0 on the top, degree 1 on the bottom. That is bigger on the bottom. The way I help you remember this is with just a little dumb saying. Bob is an outsider. Do you remember the book, The Outsider? You probably read that in middle school at least, maybe high school. I think it's middle school, isn't it? Okay. So Bob's an outsider. Well, in this case, it's whatever's outside of your fraction, that's the asymptote. Well, what? There's nothing out there. You're right. There's a 0 out there. What if I'd have had a 7 out there? Well, then the asymptote would be at 7. There was nothing out there, so it's 0. All right, let me explain it a little bit. This answer then would be y equals 0. All right, so let me give you an example of that. You're on the test and you see this function, y equals 1 over x. Well, you'll probably see that one. It's the parent of all the rational functions, right? That's the main one. This is the one you keep coming back to. That's the butterfly function. Okay. Where would that have an asymptote? 0. Well, it's got two kinds of asymptotes, Mr. Server. Which one are you talking about? Well, the horizontal ones maybe, since that's what we're about here today. That's the horizon line. That's the horizontal asymptote. Do you get how it's at 0? So some teachers actually just teach that the answer is 0, but I call it an outsider. Here's why. Do you get if I decided to move everything up 3, that's what I would do? And do you get that the asymptote would move up 3? And the kids that just think that anytime it's a bob that the answer is 0, they're toast because they're going to say 0 on the test, but it's 3. The asymptote is 3 now because it's been moved up 3. So I say it's whatever's on the outside. That'll also work for you in pre-calc. Because when you have the same topic again in pre-calc, they get more complicated and a lot more times they get moved. So if you end up moving the thing up or down by putting a number on the outside, it's whatever's on the outside. So I would put that in your notes. Bobs are outsiders. It's whatever's outside of the fraction. Okay. Next kind is the sobs. They will make you sob because they're so difficult. They're not that difficult, but it's just a dumb way to remember it. So here's the same on both kinds. 2x squared plus 3 over x plus 4 and x minus 4. And do you get a lot of people think that's bigger on the top? Think about why it's not really bigger on the top. It's actually same on both. What's the degree on the top? 2. What's the degree on the bottom? 2, because if you multiplied that out, wouldn't it have an x squared in it? That means it's degree 2 on the bottom. Okay, so these are degree 2 on the top and the bottom. That is called the same on both. The rule for that is y equals a ratio of lead coefficients. Man, that seems complicated. It's not that bad. This is the lead coefficient, and then what would the lead coefficient of this one be? It would have been 1x squared, so it's a 1. So what's the answer? Y equals a ratio of the lead coefficients. 2 over 1, so y equals 2. So you're saying, Mr. Server, that the answer to that kind is always 2. No. I'm saying the answer is always a ratio of the lead coefficients. Y equals 2 is an example. The one I gave you in red there, that one would have a horizontal asymptote at y equals 2. Last but not least, bots. This, where the other one is really, really difficult, this is super, super easy. No bot. I should put that over here, though. I should give you an example of one. What the heck is that? There's no asymptotes. If it's a bot, there's no. No. You can just say no. Give me the asymptotes. No. Because they don't have any. Let me show you an example of one that's bigger on top. Haven't you been graphing that since like 5th grade? And you didn't ever see any asymptotes, did you? Why not? Because it's bigger on the top. Now, you didn't need to worry about that till now because you didn't even know there was a thing called asymptotes. Isn't that kind of interesting? You never had to worry about it until you knew there was something. It'd be a little bit like, as you get older, you start realizing, dang, I get to worry about more and more things because I now know there's more and more things in the world to worry about. I really am a believer that you need to focus on the positive things in life because there are scary things in the world. And if you just spend all your time thinking about them, you'll be depressed. There's good things going on in your life all the time. And there's bad things going on in your life all the time. And the secret is what you focus on. It's really true. If you're having a great day, think about it. You probably were focusing on a bunch of good things. Like, oh, I'm really happy about this. I'm really happy about that. Could you take a person who's really happy and depress them? Sure you could. It would be a pretty evil thing to do, right? Remind them of all the bad things going on in their life. So, try to focus on those positives. All right, so that one's bigger on the top. And no bot, what do you mean by that, Mr. Server? There are no horizontal asymptotes. So now, this is the rapid fire round. I feel like some of you have left me and are looking at your English notes or something. Stay with me. Ready? Here we go. Bigger on the bottom, bigger on the top, or same on both? Same on both. What's the rule for SOBs? Ratio, y equals what? 2 over 1, which is 2. There you go. All right, I'm going to change it just a little bit, and it will no longer be bigger on top. Now what is it? Bigger on the bottom. What's the rule for Bob's? Bob is an outsider. What is on the outside? So what's y equals 0? Now, how could I creatively make them same on both now? I'm going to throw in an extra term here. Now it's back to same on both. What's the rule for those again? Ratio of the lead coefficient. What's the answer now? Y equals 7. Lead coefficients would be 7. And there's a 1 down there you can't see. So it's 7 over 1 is 7. Okay, and what's the one kind we haven't done yet? Bot. Now, bigger on the top. What's the rule for bots? Doesn't have any asymptotes. All right, now for the advanced round. This one usually gets people, not all of you, but it'll get a couple. Some of you are going to be so obsessed with the whole that you'll get all confused. All right, so here's my question. What are the horizontal asymptotes, if there are any? So what's the verdict? Bigger on bottom, bigger on top, or same on both, or trick question? Bigger on the bottom, Are you sure? Good, because you're right. But what are some things that people go through? Well, they think that this is degree 1, and I don't see any squareds here, so that therefore it must be degree 1, and same on both. Nope. Other people think, oh, if I cancel these, it'll totally make a difference. Actually, it won't. Because if it was bigger on the bottom in the first place, if you cancel the same thing, it's still going to be bigger on the bottom. Okay, so this is a bob. So what if there's nothing left on top? There's a 1 left on top. So it's really that. Still bigger on the bottom. What's the rule for bobs? Y equals outside. What's on the outside? 0. There's nothing out there, so it's 0. What's bots? No, no bots. Bot is no asymptotes. All right, so then to pull it all together into one big problem, here is a typical test question that would include verticals, horizontals, holes, and domain, and because we're evil, you have to get all 4 parts right to get the answer right. You gotta go 4 for 4 on this one. Okay, so be careful. I'd like you to figure out the domain. What is that again? It's what you can safely feed this function. And usually I start by saying everything works except what? Then I'd like you to figure out the vertical asymptotes, that's from yesterday, and the horizontal asymptotes, that's from today. And if there is a hole, where is it? What comma what? I think the hardest part is the second part of the hole. But I'll pause for a second while you give this one a shot. Okay, domain. I hope you knew this was everything that works. So what doesn't work? -4 and 4. I like to write it this way. You can do that way, or you can do this way. But you know what? I'm a little scared that all it would take is 1 parenthesis off and I'd have to mark it wrong. And I'm just going to count it up just so you can see perspective-wise how many things there are to write perfectly in the right order. 1, 2, 3, 4, 5, 6, 7 symbols so far. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 symbols in a row perfectly to get that way. So anyway, I'm not saying you shouldn't know that way. What if we say, put it in interval notation? Well, then you got to do it that way. But if I got a choice, I'll take it the easier way, which is a number line. Yes? Because if I put in 4, do you get it makes the bottom 0? All right. And the way I'm going to do it is by factoring. Because if you can factor it, you should. And on the top, something cancels. Boom, boom. And that made a what? Yes? You have a question? Okay, ask the question first then. Horizontal. Okay, we can talk about the horizontal. The question was, will we be asked to give the range? We don't usually do the range on these questions because it requires you to graph it. You could do it another way, but usually you have to graph it. Now, I'm not saying that you don't have to graph, but we usually don't ask range on this unit because it requires you to graph it, which is a whole lot of extra steps. We sometimes actually ask you to graph, and we'll review that tomorrow, but we don't usually ask for the range. Okay, so the horizontal. The horizontal asymptote is the horizontal asymptote, so it's a y equals thing for sure. But now I got to figure out, is this bigger on bottom, bigger on top, or same on both? Same on both? Raise your hand if you think it's same on both. All right, you're right. And if it's same on both, then what's the lead coefficient? A 1 and a 1, so it's y equals 1 over 1, so it's y equals 1. Raise your hand if you had that one right. Okay, awesome. The last one, hole. The hole is where these guys canceled. They created a hole at 4. Why 4? Because it's the thing that makes the bottom 0. 4 comma what? I never wrote the resulting function. And I'll need it now, so I'm going to do it now. Better late than never. I needed that to be able to put this 4 in to find this. So the 4 goes here, and I get 7/8. 4 comma 7/8. Raise your hand if you had 4 comma 7/8. Okay, good. All right. That sums up everything you've learned. Now, the one thing I'm a little scared about, and I've practiced this with you enough because on the test last time I was surprised how many kids got these wrong, was a different kind of question. I'm happy you're asking a question. Ask. The vertical asymptote, I don't think I ever gave it. I'm glad you said something. All right, the vertical asymptote is the other thing that makes this function crash. We already figured out 4 makes it crash, but what else makes it crash? -4. Thanks for pointing that out. It's x equals -4. Who had that one right? Okay, good. Yes, question? Or is that not a question? You have the puzzled look.
Would there so how do we know if we should choose 4 or negative?
Okay. Would you agree that these two things are problems in our function? That's why we can't put them in our domain. Those are either asymptotes or wholes. And then how do you tell which one's a whole? Because then if it's not a whole, it'll be an asymptote. Okay, so which one's a whole?
Oh, okay.
So this one was a whole, right? Remember this one? The one that canceled? And it was x minus 4s? Those are this one. This one's the whole. That means the other one must be an asymptote. Okay. And remember, if there's ever a tie, and there's like, wait a minute, there's a hole at 3, and there's an asymptote at 3, did I tell you which one is the most powerful one? The black hole. Black holes conquer everything. You can get close to the black hole. Black hole wins, just sucks you in, and you become part of the black hole. Gravity's even different in a black hole. Okay, time's even different in a black hole. Because we know stuff about space and time. And besides, I watched the movie. I can't give you a good answer, but I know that they actually are completely convinced that time moves different in intense gravity. It's almost like it slows it down. Think about it. It's like super heavy, right? It's like you can barely walk inside. Well, you couldn't walk inside a black hole because it's so much gravity at the center, you'd be just crushed instantly. It's a weird thought. But anyway, if it's a battle between a hole and an asymptote, and it seems like there's the number 3 is both things, I'll give you one. Look at this one. But, weirdly, an extra x plus 3. Can I just cancel both of them? No, that's not how math works. So, only one of them got canceled, and so I could see the one kid going, -3 was the whole. And another kid going, no, -3 is the asymptote, because see, that was the whole, and what's left over, those are the asymptotes. So I could see a good argument for both. Can it be both? No. If you look at a graph, you're only either going to see the whole, or you're going to see an asymptote. And what did I just tell you was the most powerful thing of all? The whole. All right, so the whole wins. So this would not, okay, that's a good question. Would this have an asymptote? It's a bigger on the bottom. It has an asymptote, a horizontal asymptote, though. It doesn't have a vertical asymptote. Or does it? Let me think. That's messing with my head. Okay, stop. All right. Right now, I'm just going to say that in the battle here between these two, they both seem like -3 is either a whole or is -3 an asymptote. The whole wins. We'll move on because I'll talk about graphing tomorrow. We'll talk about more of what that would look like tomorrow. Okay, so your homework for tonight. I have selected which problems you should do and which ones you should not do. For time's sake, I will pause for a second while I show you that. Okay, so tonight's homework looks like this. The first few are super simple. That wouldn't even save you any time to have you skip some of those. But the one we just did together, that's kind of like 2A and 2B. They've got a bunch of parts. Those are the most important kind. But you probably don't need that many. We're going to skip C, as in catfish. And 4C as in catfish. I just don't think I can have you can't skip anymore. It's not that long a worksheet. I think it'll be fine. All right, so let's do the first one together. Identify the horizontal asymptote. Well, I got to know, is it a bob, sob, or a bot? Which one is it? Number one. A. It's a sob. Same on both. So then that's the ratio of lead coefficients. So y equals what? 2. Next one. Is it a bob, bigger on bottom, bigger on top, or same on both? A lot of people say it's same on both, and they're wrong. What is it actually? That's a bob. Bigger on the bottom. Because why? Because this has an x squared in it if you multiply it out. Okay, so it's bob. What's the rule for bobs? Outsider. What's on the outside? 0, so the answer is 0. And you should be able to do that one last one yourself. I do say if you can factor it, you should. But in this case, you don't actually need to. Wouldn't hurt, but nothing's going to cancel. Or even if it did cancel, even if it did, it's still going to be bigger on the top. And what's the rule for the asymptotes on a bot? No bot. Very good. The answer is no. Okay, on to number 2. This is the kind we just did in class a second ago. On these, I strongly recommend that you factor them, because then you might see where something cancels and it creates a hole. Don't forget on the whole. A lot of people just write x equals something. You can't, or you'll get it marked wrong. You need to have the x and the y of the whole. Okay. And then here on number 3, I think it's the hardest question. Let me help you with 3A, and then I'll be quiet so you can work. Everybody, please find 3A and turn your iPad my way so I can see everybody is on 3A as in apple. Excellent, thank you. All right, on 3A, it says y equals 2, and I'm supposed to somehow know what the function is? Yep. But there's a lot of right answers. So let's just first of all figure out, is that a horizontal asymptote or is that a vertical asymptote? That's a horizontal. Dumb way to remember it, but hopefully that'll help. This is a horizontal asymptote. That's the kind you just learned today. So that tells me it's either a bob, sob, or a bot. Can I tell for sure? Well, the one thing it can't be is a bot, because otherwise it wouldn't have had any asymptote. Could this be bigger on the bottom? Yeah, it could be bigger on the bottom, and then we could just put the 2 on the outside. Or this could be the other kind, which is the same on both kinds, and then I need the ratio of the lead coefficients to be 2. So this is tricky, but it's not impossible. I now know that it could be bigger on the bottom, because then that answer could be 2. It'd just be a 2 outside. You get what I'm saying? I'm going to go that way. Next, x equals -3 is an asymptote. What kind of asymptote is that? Vertical. That's a vertical asymptote. Those come from here. Now I need something on the top. Could I put anything up there? Sure. Doesn't tell me what has to be on top. Is that a bob? Yep. So it's an outsider. And it's got the other 2 asymptotes. Yay, that's an example of one. All right. There's a key. Do it. Check it. Have a great day.